All right, here's the second half of our review for Chapter 4, so 4.4 through 4.7, and let's see how fast we can get through this. All right, 4.4 was corresponding parts of congruent triangles, so that was our friend CPCTC, and looks like we've got a couple of proofs to do here. All right, let's take a look. First thing I see parallel lines. So that is making me automatically think alternate interior angles. And it looks like we have some congruent sides here that were given those. And we want to prove that angles are congruent. So this says CPCTC. So we need those triangles, MLN and triangle ONL. So MLN, there it is, and ONL, the upright and upside down one. So let's do a little bit of redrawing here. So here's our triangles, and we've got this guy comes this way, and well, we can mark this however. Got some reflexive. I can't stop myself from marking the reflexive. And this side are given to us. And then our parallel lines. How are we going to use those parallel lines? Well, let's draw some parallel lines. Now we've got a couple options for transversals here, but we really want angles that are going to be in both of these triangles. So I'm thinking this middle line to be our transversal because that line is associated with both triangles, and then we can just kind of dot in. Well, sorta. I didn't get this one angled enough, but that's okay. Now I need to find which of my angles are inside my triangles here. So I know I'm looking for alternate interior angles. It's those guys right there. So now I'm going to come up here on my triangles and find those. That's there, and there's this one and this one. You can kind of see it now. So that's alternate interior angle theorem. So we've got side angle side. I can see side angle side here. Do you see side angle side? So that gives us a side angle side. So we want to do a proof that does side angle side, side angle side, and then I'm going to make my triangles congruent, and then I'm going to use my corresponding parts down here. So let's go through and see, where did we get our first side? Well, we can just use our given one. That was LO's congruent segment MN, and that was given to us. And then angle, where do we get our angle? All right, this is going to take a couple of steps here. First step is we were told that these lines, line LO and line MN, are parallel. That's given to us. And then that lets us say that these angles are congruent. Oh, I'm a terrible, terrible person here. I did not label my triangles. How could you let me get away with that? All right, so what are my angles? OLN, we could do angle OLN is congruent to angle, and I went across purple side and down green side, so that's going to be across purple side is angle MNL. And what lets me do that? That's alternate interior angle theorem. Lets me say those. So I'm given the parallel lines, lets me use alternate interior angles. So I now have congruent angles. Now I'm looking for that other side. That was our reflexive side, so that's supposed to be an N. Segment LN is congruent to segment NL, and this bothers me every time I do it, because we should make them congruent and then use the symmetric property to switch them, but that's okay. That's the reflexive property of congruence. It's not something I will count you off on a test, but should be Ln is congruent to Ln, and then the symmetric property lets us say Ln is congruent to NL. Anyhow, now let's make our triangles congruent. We need to make those triangles congruent. So which triangles are we looking at? We might as well just use the ones that are our angles. So it starts MLN. Can I do MLN? I can. It's not how I would name it, but MLN is congruent to, so let's go find, we started at the blank angle, went the blank side, and then down green. So that's triangle ONL. And we used the side angle side postulate to do that. And now I want to make those angles congruent. Well, the reason that I deviated from the normal way that I would name the triangle, which is choosing like side 1 to angle and then side 2 so that it's easy, is because look at what we're trying to prove here. Angle MLN is congruent to angle ONL, and it's already in the right order because it matches my triangles, right? So I did my triangles in the order of the angles that I wanted. So I know if my triangles are congruent, I can use CPCTC to make any corresponding parts congruent. So yay! That wasn't terrible. All right, let's see what the next one wants from us. This is another CPCTC, right? Because we're looking for angles to be congruent. Where's angle A and angle B? So I want this angle to be congruent to this angle. All right, and let's look at what we're given. I'm going to redraw here so things are a little bit bigger so that I can mark on it. Sometimes it's easier to see things when you draw them larger. I'm not doing a very good job here. That's all right. I will label this time though. P, A, O, B, Q, O, an angle 1, an angle 3, an angle 4, an angle 2. All right. And, oh, we are told that length PO equals length QO. Check that out right there. That's an equal sign. So PO equals QO. That's the length. I'm going to have to use definition of congruence to make those congruent because I am given the length is the same and definition of congruence says they're congruent. Oh, and check it out. The angles are the same. The measure of angle 1 equals the measure of angle 2. So to make them congruent, that's another definition of congruence. And in the middle here, I see vertical angles. You don't know how hard it was to wait till now to mark those. Vertical angles. Okay. So, we need angle 4 and angle 3. How are we going to get this angle, not the color I want, there we go, this angle and this angle to cooperate with us? Well, what do you see going on up here? Let's do a little more redrawing. We have angle 1 and angle 3, and we have angle 4 and angle 2. What do you notice about those? Do you see the linear pairs there? We know that linear pairs are supplementary, and we know that angle 1 and angle 2 are congruent. So color do I want here? I need a different color. These are linear pairs, and what do linear pairs tell us? That our angles are supplementary. And why am I making them supplementary? Because we have a theorem about that. It says that if two angles are supplementary to congruent angles, then your angles are congruent. Running through my head here trying to remember exactly what it says. Check your chapter 2. This is your congruent supplements theorem. All right, so how are we going to put this together? Well, I can get these angles congruent. We'll have to talk through that when we get that. But that's not quite what we're doing now. We're figuring out how to do it. I know I'm going to use the congruent supplements theorem and linear pair postulate. So what do we have? Angle, side, angle? I see angle, side, angle. So let's figure out how to get angle, side, angle here. Angle, side, and then that last angle is going to take some space. So I'll leave a little space, make my triangles congruent, and then use my corresponding parts down here. So the first angle was really easy. That was our vertical angles. So angle POA is congruent to angle, that would be up the blue side, QOB. And that is vertical angle theorem. And how did we get our side? We were told that the length of PO equals the length of QO. That's given. And then what do we do with that? We can say segment PO is congruent to segment QO by basically the definition of congruence. Right? We're given equal length. This right here is equal length. We have to make our angles congruent. So we use definition of congruence. Now, how are we going to get that angle? There's a few steps involved in this. The measure of angle 1 equals the measure of angle 2. That's a given. So I can say angle 1 is congruent to angle 2 by definition of congruence. I'm going to erase these because I think I need more space. All right, so I've got angle 1 is congruent to angle 2 now. And what am I going to need to do? I am going to need to say that angle 1 is supplementary. Let's write it differently. Angle 1 and angle 3 are supplementary, and angle 2 and angle 4 are supplementary. That's just linear pair postulate. Okay, so I've got those supplementary, that angle 1 and angle 4 are supplementary by the transitive property. No, that's not a transitive. That's more of a substitution. We'll call that a substitution. I wouldn't grade you off if you said transitive. So now I've got 1 and 3 and 1 and 4. This is more appropriate. So now 3 is congruent, angle 3 is congruent to angle 4 by the congruent supplements theorem. And then I'm going to be able to say that my triangles are congruent. So now I can do congruent triangles because I've got all my angles and all my sides. And doesn't matter. Triangle PAO is congruent to triangle QBO by angle side angle postulate, which lets me then say that angle A, I want a better color than that. It's a red. Angle A is congruent to angle B. Look at where they're at in our congruent triangles. They're in the same position. So CPCTC. All right. So that one was a little bit of a challenge, but a nice throwback to Chapter 2 and congruent supplements and linear pairs. Okay, 4.5 was isosceles and equilateral triangles. We want to find the variable for each, the value of the variable for each of these. So the first thing I see is an equilateral triangle, which means I know that it's equiangular, and I also know that they all measure 60 degrees. So this one is straightforward. 2x plus 10 equals 60. Subtract 10. 2x equals 50. Do my algebra. And x equals 25. So there's that one. And that's just the corollary to the isosceles triangle theorem. Lets me do that. Let me mark my angles congruent, and then I know they're all 60 degrees. All right, what's next? Oh, we've got 3 angles here. I see an isosceles triangle, so I know x and z are congruent. And do I have a way to find x or z? I do. I can use my exterior angle theorem. And nope. It might be an exterior angle. That's not what I'm going to use, though. I'm going to use my linear pair postulate and say that 135 plus z equals 180. And subtract 135 from both sides. So I'm going to get z is 45 degrees. So I can come up and label 45 here. And then x, I know that x equals z. So x is also 45 degrees because it's an isosceles triangle. So that's 45. And then I can just simply use my triangle angle sum theorem to say that 45 plus y is 180. So subtract 90, y equals 90 degrees. So I have a 45, 45, 90 triangle. You will come to enjoy those later. All right, and the last one. Oh, I've got congruent angles here. What does that let me do? Makes me want to mark my sides congruent. That's the converse of the isosceles triangle theorem. Lets me do that. And so if they're congruent, I know the lengths are equal. So minus 3x, 4x minus 10 equals 6. Add 10. Both sides, 4x equals 16. Right by 4, and x equals 4, and that's all we were asked to do. We weren't asked to find angle measures or anything. We could easily plug them back in. All right, this proof is too complicated to put into a review. We're going to skip it. Yay! Back to our previously scheduled program. Go to 4.6. This was congruence in right triangles. This was our friend HL theorem. And I have a feeling we're going to be dealing with right triangles. Remember, HL theorem, our requirements are HL theorem, the hypotenuse, the leg, and a right triangle. So let's see what we're given here. Segment RT is congruent to segment US. and URS and TRS are right angles. All right, let's redraw. We're going to be using this triangle and this triangle. So here's RSU and RST, and I can't help myself but mark those reflexive, and then go here and say that RT is that, and US is that, and then my angles, URS is a right angle. I didn't label this. This is given to us. And TSR is a right angle. And so this means I'm going to use right angles and turn them into right triangles because I have a hypotenuse here and a hypotenuse here, and they are congruent. And I see a leg here and a leg here and right angles. So I'm going to use the HL theorem, which means first thing I need to do is make a right triangle and then get a hypotenuse and a leg, and then I'm going to make my triangles congruent and then use my corresponding parts because this is CPCTC. All right, so right triangle. Well, I am told that angle URS and angle TSR are right angles. That's given. So I am going to say triangle URS and triangle TSR are right triangles. Notice how I just kept them in the same order. That's by definition of right triangle. I have a triangle with one right angle. It is a right triangle. So I have my right triangles. Now how do I get my hypotenuse? That was RT. Segment RT is congruent to segment US. That's just given to me. And how do I get the leg? Well, that's segment RS is congruent to segment SR. Yes, I really feel the symmetric property. That was the reflexive property of congruence and a little symmetric property. And then I can say my triangles are congruent. Which triangles are congruent here? Well, let's see. Triangle RUS or RSU. Let's go RSU is congruent to triangle, because then I went across side 1 and then down side 2. Started at the right angle, SRT, and that is HL theorem, because I met my requirements. And now, what am I trying to prove? That angle T is congruent to angle U. Are they in the same position? Yes, they are. CPCTC. Okay. Next proof. M is a midpoint. So midpoint tells me two congruent segments, midpoint of AB. I'm going to go find AB. There's my midpoint. I am going to mark those congruent and make my little note. That's definition of midpoint. And, ooh, we've got some perpendicular things going on here. Perpendicular, perpendicular, MC and AC, and so perpendicular, I know that perpendicular leads to right angles, and right angles can either lead to congruence or to right triangles. I have a feeling it's right triangles. We are in the HL section. And angle 1 and angle 2, that's just a given. Oh, what does that let me do? Check that out. That is the converse of the isosceles triangle theorem. I've got HL. Let's redraw these and take a look at what we got. We've got this triangle here, and this triangle right here, M, B, D, C, A. So I've got a right angle there, and a right angle there. And this was my isosceles, converse of my isosceles triangle theorem. Converse of isosceles triangle theorem, right? That let me do that from the triangle in the middle. This is given. Always good to know where your hypotenuse is. So my hypotenuses are congruent. I've got congruent legs, and I can turn my triangles into right triangles. So let's do that. We need a right triangle, we need a hypotenuse, we need a leg, and this time we're just looking for congruent triangles. So how do we get our right triangle? Well, we are told that MC segment is perpendicular to segment AC, and segment MD is perpendicular to segment BD. That was given to us. So what does that let us say? That lets us say that angle ACM and angle BDM are right angles. Right? We turn things into right angles. That's just definition of perpendicular. And now, since we're using HL, right, we decided on HL here, we don't want congruent, we want right triangles. So I am just going to say triangle ACM and triangle BDM are right triangles. Notice how I just used the same thing as I did angles. Definition of a right triangle. Triangles with a right angle. All right, now, move this down a little bit. That was our, we've got right triangles, first requirement. Now I need congruent hypotenuses. Where do those come from? Well, that is segment no, that's not given. Where did the purple ones come from? Purple ones up here. Definition of midpoint. So we were told M is the midpoint of AB, segment AB. That's given to us, which lets us say that segment AM is congruent to segment BM by definition of midpoint. All right, where did our leg come from? Our leg, we were told that angle 1 is congruent to angle 2. That was given to us. So we can say that segment CM is congruent to segment DM by the converse of the isosceles triangle theorem. All right, and that gives me everything I need. Which triangles are congruent? Triangle ACM, let's check this. ACM is congruent to triangle BDM. BDM, yep, that's what I was asked for by the HL theorem. Okay, so that one wasn't too bad. That was more what I was looking for in proofs than the last one. Last one was a little bit long. 4.7. Congruence and overlapping triangles. We are supposed to separate and redraw the overlapping congruent triangles in each diagram, identify the overlapping parts, and state whether they are congruent. Alrighty. So if I look here, I see this triangle. I'm going to draw here, RAF, and I see this triangle that I'm going to redraw here. It's a hint for the 4.7 homework. OAF. And we're told this and this and this and this. Oh, wait, not that. Not told that. But we are given 2 plus 2 there and 2 plus 2 there. And we're given right angles. So this is HL theorem. So segment AR is our overlapping part, and these are congruent by the HL theorem. Right, so we've got a hypotenuse, we've got right triangles, we've got a hypotenuse, and a leg. Okay, what do we got going on here? I'm going to say it's the big triangles. Let's look at this one. So that's here, T, R, G. And then we want to separate this out here. And that is here, O, G, S. So who's common to both of them? That's angle G. Right, see angle G there on both of them? So angle G is common, and we should put 2 marks on it because we've already got an angle down there. What are we already given? This and this, and this and this. Yes, we could make them congruent. Angle, side, angle, postulate. All right, that was fun. And this one looks a lot easier. There's my first triangle, M, so Q, R, and my second triangle here goes to there, Q, R, S. Did you hear it when we said it? Segment, it's supposed to be red, segment Q, R, common to both. Actually, that one's going to need 4 of those. 2, 3, 4. 2, 3, 4. Because we have lots of other stuff already marked. 1, 2, 3. 1, 2, 3. And then here, our long sides are 2 plus 1. Right? And 2 plus 1. So, side, side, side postulate on that one. Alright, so that was a good exercise in redrawing and labeling. Looks like we've got one proof left. Alright, this last proof has some overlapping triangles. I see a whole bunch of overlapping triangles here. What is it that we want? We want segment AS and segment AL to be congruent. Alright, so we are looking for those pieces. Let's start out by redrawing everything we've got. So, start big triangle here. R, A, L. And then I see these 2 overlapping. This one, that's not the color I want. This one here and this one here. You see those? Because what I see is a common angle up there. So let's redraw those. So that's like this. This is R, I, A. And its pal here goes like this. This is P. It's a P, R, L. Okay. And we might as well just mark this common angle here and call that reflexive, because that's why we did that one. And we've got a bow tie here in the middle. So sometimes it's easier just to draw like that. That doesn't look very good. So we've got our bow tie. It's going to come down and up. And that's A, L, I, S, P. And I really feel the need to mark some vertical angles there in the middle. And they have a given angle there. That could be useful maybe. And it also contains our SA and SL that we want to make congruent. We'll have to see if we can get something else on that triangle. And we've got one more triangle here. This guy here at the bottom. ALS, which also contains these pieces that we want. So that might be useful. And that has a common side here and here. Don't know if that's going to help us any, but it's a common side, something we can look at. All right, let's see what we've got. Let's define, explore this one. I can tell already there's not enough room to write a proof, but we can see what we're capable of. We've got these angles in these triangles that are given. All right, anything else we can do with that? Let's see what else is given to us here. Segment AR and segment LR. That's this here and this here. They're also here and here. Well, that gives us angle, side, angle in this triangle. It also gives us, how many am I on now? 3? Let's do a better color for this. We've already used our purple. Oops. Oops. I didn't need to erase those. These were the given angles, given purple. And redraw my ARL here. Let's use blue. Blue, these are blue. These are given to us. Blue is given. That also gives us these angles here. Do those angles belong anywhere else? No, this is isosceles triangle theorem. I don't see those angles anywhere else. Okay, we've got these congruent here. Let's look at those on our diagram. We've got this is congruent to this. Does that help us with anybody else? It's not going to help us with our bow tie. It's not going to help us with this single triangle here. Well, we can make the triangles congruent, but it doesn't do anything for us. So what are we going to have? Well, we know, I think we're going to have to do the big triangle and the little triangle here at the bottom, because we've got these blue angles here that we did by isosceles triangle theorem. We've got these given angles here. Okay, those are the ones we're going to have to use. So we don't need that. We don't need that. So we need these two triangles. Let's do another redraw. Here's my big triangle. Here's my little triangle in the middle. This is L, A, S, R. And I know this, make those two like they were before. I know these two angles, okay? And I was given this angle here and this angle here. So if I can get green angle and green angle, that's going to give me this and this, and then I could make these sides congruent. I don't know how many lines I'm on by this point, using the converse of the isosceles triangle theorem. So how would we get green angle? Well, I know angle blue equals angle purple plus angle green, right? And that's true on both sides. We'll call this angle 1 and angle 2. Blue 1 plus purple 1, or equals purple 1 plus green 1, and angle blue 2 equals angle purple 2 plus angle green 2, right? Right and left. You could do left and right. So the left side over here and the right side over here. And what do I know about blue 1 and blue 2? They're the same angle. And what do I know about purple 1 and purple 2? They're the same angle. So that would make this green angle here congruent, right? Green angle 1 congruent to green angle 2, which would give me what I needed to use my converse of isosceles triangle theorem. So that's how we would work through that one. We were able to make triangles congruent, didn't need them. Had nice little bow ties with vertical angles, didn't need them. It turned out all we needed was the big triangle and this little triangle inside of it here to get those sides. So I'm not really making you write proofs on these, just know that that's how it goes. We will use this idea, but these are pretty complicated. A lot of stuff going on in them. All right, so what do we need to remember most? I would say the highlights. Know how to do your perpendicular to right angle to right triangle for the HL theorem. And back up here at this one, parallel lines makes you look for alternate interior angles. And back in 4.3, know how to do your perpendicular to right angle to all right angles are congruent. This right here is a really good proof. It's got all right angles are congruent, alternate interior angles, little reflexive property thrown in there, and make some nice congruent triangles. And don't forget CPCTC. These two proofs right here are really good. CPCTC to get those pieces that we can't mark any other way. So a lot of good stuff in there. Have fun with your proofs and good luck studying. We will end down here at the bottom, looking at this. All of those overlapping pieces. Again, draw, 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 label, 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 and color is good. Geometry is so much easier in color. All right, and good luck on the test.